Okay, here in this video, we're going to look at solving quadratics by using factoring methods. And so let's look here at our first problem where we have p squared plus 7p plus 12 is equal to 0. So some of our steps here in order to solve by factoring is if you see you have a p being squared or a variable being squared and the variable to the 1 power, you want to make one side of your equation equal to 0 and then proceed. So this one already has one side equal to 0, everything else on the left. And so from here, we want to work our way into solving. Well, we're going to look, and by factoring, we're looking at this. We have 1p squared, so that means we're going to have these two binomials. And the only way to make p squared using whole numbers, they're going to be p times p. Now we're looking to figure out, well, what times what makes 12, positive 12, that will add together to be positive 7. Well, if everything has pluses, I know I'm going to have pluses inside my binomials, and 4 times 3 makes 12, and 4 plus 3 makes 7, so there's my pair of numbers. Now from here, what you're going to do is you're going to take each factor, a factor B is like p plus 4 and p plus 3, I'm going to take each individual factor and set it equal to 0. So I'd have p plus 4 is equal to 0, and I'm going to have p plus 3 is equal to 0. And then you solve these two little math problems here for p. So for one of them, I'd minus 4 from both sides. That's going to give me p is equal to negative 4. And then for the other one, I'll minus a 3 to both sides here, and that's going to give me p is equal to negative 3. So the two values we have for p are negative 4 and negative 3. Now let's go check our answers in Desmos. Okay, so graphically, I'm graphing y equals x squared plus 7x plus 12. No, I don't need to write a secondary equation here in Desmos of y equals 0 because our solutions to these problems when I have one side of these equations equal to 0 are going to be the x-intercept. So I'm going to go look at my graphs, figure out where does it cross the x-axis, and it crosses the x-axis at negative 4 and negative 3, which is the same answers that we got for p. All right, new problem here. So this time I want to solve for p. Again, we got 8p squared minus 56p plus 3 is equal to 3. So what I do here is because I see a p being squared and a p to the 1 power, I'm not going to do my traditional solving methods for linear equations, or even if I just had one p, since I got two separate p's that I can't put together, we're going to make one side equal to 0. So I got to move this 3 to the left-hand side so that I have a right-hand side of 0 in this case. So I have minus 3 from both sides. That's going to give me 8p squared minus 56p. Those 3's cancel, and I got equals 0. So from here, our method to solve, well, everything on the left-hand side has p's. And I also have a common factor between 8 and 56. So I'm going to take out my greatest common factor, and then I'm going to solve. And so the greatest common factor between 8p squared and 56p is, well, they both have p's, but also 8 can go into 8 and 8 can go into 56. So I'm going to pull out an 8p from the outside. And so when you're factoring by pulling out GCF, you got to divide what you originally had by what you pulled out. So 8p squared divided by 8p just leaves me with a p. And then 56p divided by 8p, well, the p's will cancel. 56 divided by 8 makes 7. Now from here, what you're going to do is you're going to set the two factors equal to each other. Well, one factor is the 8p, and the other factor is what's in parentheses. So I got 8 times p is equal to 0, and I got p minus 7 is equal to 0. And then we'd solve for p in both cases. So I'd add the 7 over for this one. I get p is equal to 7. And then for my other expression, I would divide by 8, and that's just going to give me p is equal to 0. So my two answers here are 0 and 7. Let's go confirm that in Desmos. All right, so I graph it in Desmos, and I changed my zoom window here so it's a little easier to see. Notice I only graphed the expression after I got it set equal to 0. So I graphed the 8x squared minus 56x. Instead of using p's, I used x's. Our answer here is where it crosses the x-axis. So we got 0 for an x, and we got 7 for an x. Same solutions that we got when we did it. All right, next problem. I got 5x squared is equal to 7x minus 2. Well, since I have an x to the second power and I have an x to the 1 power in the same problem, I need to get everything on the same side. So I'm going to move everything to the left-hand side. So I'm going to minus the 7x, and I'm going to plus the 2. That's going to give me 0 on the right side. The left side will be 5x squared minus 7x plus 2. And then I'm going to, hopefully we can factor this. And so we're lucky because we got two prime numbers we're working with here. So 5x squared is created by having a 5x times a 1x. Now, with factoring, if I have to add together to be a negative number, but multiply it together to be a positive number, that means both numbers are going to be negative. So I got to figure out, okay, the two numbers that multiply together to make 2, that will add up to make 7. And, well, my only options are 2 and 1, so I got to figure out, well, does the 2 go here, or does the 2 go here? Well, keep in mind this 5x is going to multiply to whatever number goes there. And then the 1x is going to multiply to whatever number goes here. Well, to make a 7, that means I have to have a 1 here and a 2 there, because 2 times 1 makes 2, 5 times 1 makes 5. Add them together, we get our 7 in the middle. So, now that we have it in factored form, we're going to set each factor equal to 0. We're going to solve for x. So 5x minus 2 is equal to 0. X minus 1 is equal to 0. We'd add the 1 over here, and that gives us an x value of positive 1. And then in the other one, we would add the 2. And so we have 5x is equal to 2. And then you would divide by 5. And we get a fraction here, which is okay. X is equal to 2 over 5. And so let's go confirm our answer in Desmos. And what I'm going to do is I'm going to graph this expression there. All right, so I graph 5x squared minus 7x plus 2, and I want to see where it crosses the x-axis. We got an x-intercept here at 1, which is one of our answers, and the other one is at 0.4. Now, 0.4 is the same thing as 2 divided by 5. All right, next problem, we got 14x squared plus 10x is equal to negative 39x. And so we want to solve this problem here. Now notice how, again, notice here, again, how I have x being squared and I have an x to the 1 power. So as soon as I see that, I got to get everything on the same side. So let's take this negative 39x and let's add it over here to the other side to be with the rest. So I add 39x. And I go combine like terms, and so my right side is 0. I combine the 10x and the 39x. That's going to give me 49x here, and then we have 14x squared. Well, from here, we take out our greatest common factor because I only have two terms. So I'm going to make one set of parentheses, my GCF. I can take out of x, and also a 7 goes into 14, and so does 49, so I'm pulling out a 7x, and it's going to leave me with 2x plus 7 inside, and then we solve both of these for x. So I get 7x is equal to 0, and 2x plus 7 is equal to 0, and we solve, so we get x is equal to 0 for this first one, and then for the second one, we'd have to minus the 7. That gives us 2x is equal to negative 7, and then you would divide by 2 on both sides. That's supposed to be a negative, and you get x is equal to negative 7 over 2, which is the same thing as negative 3.5. Now, I'm going to do this one a little bit different. Here's one of all the other ones. I graphed this and found the x-intercepts. For this one, I'm going to actually graph the top equation, and I'm going to go y equals the left and y equals the right, and we're going to see where the two graphs cross, and we should get the same two x values. All right, so here I graph my two lines, and I look and I see one point of intersection here at 0, 0, where the two lines cross each other. Now, to go find the other one, we're actually going to have to change our zoom. So we're going to have to zoom out, and we zoom out to see where the lines touch at. Now, it's going to be, you might have to do a couple of zooms to look and find, but they do cross a second time. And so I'm going to look at where they touch, and they cross at negative 3.5, which is the same thing as negative 7 over 2.